Welcome to Millionlights. My name is Pratik Shah. I am an assistant professor in DY Patil School of Engineering. In the previous module, we had discussed about serial communication. With the help of serial communication, how we can control various devices. Along with that, we had seen LDR, that is light dependent resistor. Along with that, we have seen how to measure the light intensity. Now, in this module, we'll be discussing two things. One is passive infrared sensor, which is used for detection of motion or human presence. Along with that, we'll be discussing LM35, that is a temperature sensor. Okay, so let's start with passive infrared sensor. Now, this is how passive infrared sensor looks. This is used for detection of human or motion. Now, it has got three pins. One is VCC, the third one is ground, and the middle one, that is for output. Now, this is a digital sensor. It will give an output that is 5 volts or 0 volts. So, if it detects any motion or presence of any human, then it will give you 5 volts from this center pin. Now, this sensor is receiving infrared heat signals. So, it receives infrared heat signals, and depending upon that, it detects the presence of human or motion. The name of this sensor is passive infrared sensor, and to be technically specific, the name is HCSR501. Now, the range of this is 7 meters, that is approximately 21 feet, and it has a angle of 120 degrees. So, anything that is in the range of 120 degrees and 21 feet, it can detect it. Now, we have seen the architecture of it. Now, along with that, if you take a look inside this part, now this is a complicated circuit. Now, it has got a lot of ICs, resistors, capacitor and all, but we need not think about that at all, because we just have to focus on these three pins and how we can do it with the help of Arduino. So, it is complex and complicated, but we need not worry, because simply these three pins are what we are going to use, and then we'll see about programming and all the stuff. Okay, let's start with building the circuit. The aim of this experiment is to detect any motion, and if a motion is detected, we have to indicate it using a LED. So for this experiment, we require passive infrared sensor, then Arduino, then this USB cable is required to connect Arduino with PC. We'll require this LED for indicating the output, and then we'll require this male to female connectors. Now, in the previous experiments, we have used male to male connectors, but this time we are going to use male to female connectors because they easily get fixed into these kind of slots. So, this is it. These are the things that we'll be requiring. Very few things we are requiring, and the setup is also very simple. PIR sensor is our input, and the PIR sensor has got three pins as already discussed: VCC, ground and output. So the VCC pin is connected to VCC of our Arduino board, ground is connected to ground of the Arduino board, and the output is connected to pin number 7. So it is simple, three pins going at three places. Just one thing to note, that output of this is going to pin number 7. Then we'll be using an LED. LED will be an indicator of motion detection, and this is connected to pin number 13. So anode is connected to pin number 13, cathode is connected to ground. So you can either use a breadboard and you can keep LED on the breadboard, or else what I'll do is I'll use a shortcut. I'll place it on the pin number 13 and the cathode will be on the ground, since ground is available on the same slot. Okay, so 8, 9, 10, 11, 12, 13. So at pin number 13, we are connecting anode and cathode is connected to the ground. So the output part is clear. Now we have to make connections about the input part. So input part connections. This is VCC. VCC goes in here. VCC goes on the onboard VCC. Then I'll take ground. Ground also is connected to the onboard ground, and then the center pin, that is the output, it is connected to pin number 7. Now I'm connecting to pin number 7 because this is a digital sensor and it will give output which is 5 volts or 0 volts. Okay, so the setup is quite simple. I think 3 pins going on to Arduino. Only 2 input and outputs we have. One input is from PIR sensor and the output is your LED. So this is the setup of the circuit. Now one more thing is left out, that is connecting our Arduino to the PC. So we'll be using this USB cable, and with this I can connect it to PC. Okay, now the setup is complete. We'll see the program and after that the logic behind it, and then we'll finally see the output. Now let's start with the programming part. Now as you can see in the program we have got one input and one output. So let's first think what will be the program like. As you all know, the programming will be split into two functions, void setup and void loop. The initializations will be done in void setup part, and things that are to be continuously executed, they will be there in the void loop part. Now as you can see in void setup we have got two pin modes, that is initializations of input and output. Pin number 7 where we have connected the output of PIR is supposed to be the input. Then pin number 13 is the output from Arduino because we have connected an LED over there. Therefore we'll receive the input to pin number 7. So if it is high, that means there is a detection of any motion or a human presence is there. Then then subsequently we have to see that pin number 13 is high. So the initialization part is very simple, two pin modes. Along with that I have done one more additional part, that is digital write 13 low. So I have made the pin number 13, that is LED, to be low initially. Now we'll see the void loop part, that is the programming part. Here the first thing is if condition. That is, first we are checking for the output of the PIR sensor. So we'll read the pin number 7 with the help of digital read instruction. So if it is high, that means if a motion is detected, then we are going inside this if condition. So if a motion is detected, then only this part is executed, else nothing is happening. So what are we exactly doing inside this if condition? First thing, digital write 13 high. That means we are switching on the LED. So when a motion is detected, then we are going inside this if condition and we are switching on the LED. After that we are giving a delay for 4 seconds. A 4-second delay is given so that there is sufficient amount of time that the LED is on and everybody can understand a motion is detected. After that we switch the LED off. So for 4 seconds the motion is detected and it is displayed, and then once again we are ready for detecting the motion. So the programming is quite simple, void setup, void loop, initializations are there in void setup, and in loop the execution part. In loop only if condition is there where we are checking whether a motion is detected. If a motion is detected, switch on LED, have a delay of 4 seconds. That's it. So the programming is quite simple. Now what we will do is we'll type this program in our Arduino IDE and we'll dump it onto the hardware. Okay, now let's start uploading the code. I have already written the code onto Arduino IDE. I'll press this upload button. Okay, so the code is getting uploaded onto the Arduino board. Okay, so it's uploaded. Now let's check it out. If I place my hand over here, then the LED should be switched on. Okay, so it's having a delay. Okay, so we uploaded the code. Now when I'll place my hand onto the PIR sensor, the LED should go on. So it's taking some time, but it's getting on. Once again it will be switched off after 4 seconds of delay. Then we can once again check whether it's working properly. Okay, so now the time is passed. Once again we'll check. Yes, it's working properly. Now it will be on for 4 seconds, as in the program we have written a delay of 4 seconds. So after that once again you can check it. This kind of things are used in a lot of places. Yes, once again the output is perfect. These are used in malls and all the other places. Okay. We have seen the output of this circuit, and now we'll talk about the application of this. This is used in lot of places you might not have understood also. It is used in malls. When we make an entry, at that time you can use passive infrared sensor or proximity sensors, so they are used there. Even in washrooms We have wash basins where you just put your hand and automatically water starts coming. We don't have any knob there. So at that place also we can use passive infrared sensor, or I'll give you a one application that you can make on your own. You can use passive infrared sensor, and instead of switching on LED, you can use a buzzer to make sound, and it can be used at night in your home. So you can place it in your home or in your garden. So if some thief or if any person is coming, then you will be alarmed and you will be knowing it before, so that it can be good for your safety and other purposes. So there are a lot of applications where you can use it, and it's a very good circuit and a very simple thing, less than 500 rupees when you can make a circuit out of it. Now after completing it, we'll be starting with LM35, that is a temperature sensor. So in the next experiment we'll be learning how to measure the temperature and what all things we can do with it. Okay, now let's start with the experimentation with temperature sensor. For measuring of temperature, we can use lot of things such as thermocouple, thermistors, LM35 and all other stuff. But the problem with thermocouple thermistors is that we require a signal conditioning circuitry, a calibration circuitry, and that becomes a lot of work and lot of calculation. So instead of using those things, I'm using this tiny little sensor called as LM35. Now this sensor is having just 3 pins. It does not require any signal conditioning circuitry, and we can directly use it and it will give us the results. Now how it works and all we'll see, but before that let us take a look at it. It is a IC which is having 3 pins, 1, 2, 3, and out of these 3 pins, one is 5 volts, this first one, the second one is the output, and the third one is the ground pin. So 5 volts and ground, they are the same thing that we have seen, and the center one is output. Now one thing that we have to note is that this is an analog sensor. That means the output will not be just 5 volts and 0 volts. The output is an analog voltage, and that output is proportional to the things, that is the output is proportional to the temperature. Okay, so 5 volts ground and then the output. Now regarding the range of it, the range of this sensor is from minus 55 degrees to 150 degrees. That means we can measure a temperature from minus 55 degrees to 150 degrees, and the output will be proportional to it. Now what is the meaning of proportional? Now I'll tell you, the resolution of this sensor is 10 millivolt per degree Celsius. So it will generate 10 millivolt of voltage for corresponding change in 1 degree Celsius of the temperature. So if suppose the temperature is 40 degrees, it will generate an output voltage of 400 millivolts, that is nothing but 0.4 volts. So if the temperature is 30 degrees, it will generate 300 millivolts output, that is nothing but 0.3 volts. Okay, so if we are having a temperature of minus 20 degrees, then it will generate an output of minus 200 millivolts, that is 0.2 minus 0.2 volts. Okay, so the output is proportional to that and it is calibrated accordingly, so no more calibration formulas and all the things are required. Then the range is from minus 50 degrees to 155 degrees, so the output will be from minus 0.5 volts to 1.55 volts, and that voltage has to be measured, and accordingly we can say the value of degree Celsius in that. Okay, so the thing is quite simple. 3 pins, VCC, ground and the output pin, and no other signal conditioning circuitry, no other calibration circuitry. Let us see about more important things. This is having more accuracy than thermistors, so it is one more advantage, and it gives output voltage in directly degree Celsius. Then the resolution is 10 millivolts and the range is from minus 55 degrees to 150 degrees. Okay, so these are the basic things about this sensor. Now we'll see how to connect it and how to make a circuit. Okay, now let's see how the circuit will look like. In this presentation I have prepared a circuit diagram of it. Now we can see we have got very little connections here. Just 3 pins are to be connected from LM35 to the Arduino board. As seen earlier, 5 volts and ground pins are to be connected to the respective terminals of your LM35, and the center pin, which is the output, that is connected to A0 pin of the Arduino, that is analog 0 pin. Now this I have already iterated. Digital is 0 volts, 5 volts, analog is from 0 volts to 5 volts in a step. So this will give us output in analog manner, as we have discussed earlier, 10 millivolt per degree Celsius. So we have to measure it with the help of analog port, and that's why I'm using A0 port in here. So this is how the schematic will look like. Arduino pin A0 is connected to the output of the LM35 and VCC and ground are connected to the board. So the circuit is quite simple. Now we'll build the circuit and then we'll talk about the coding part, and we'll see how we can code it and how the output can be obtained. Okay, so now let us see what are the components that are required for performing this experimentation. First of all, we'll require LM35. This is the most important part. After that, we require Arduino board. It is required for connecting this and PC. Then we'll be requiring the USB cable for connecting it with the PC. Once again, we'll require jumper wires, that is male to male connectors, and then we require the breadboard. We require breadboard because we'll be placing LM35 onto it. Now let us see or talk about the expected output of this experiment. In this experiment, we'll be measuring the ambient temperature, and that will be displayed on the screen. So we have serial communication here, and we are just measuring the temperature and displaying the value of the temperature. So we are not having any output device as such. We are not having LED buzzer or any other thing. We are just measuring the temperature of the surrounding, and that is displayed onto the screen. So no other device is required. Now let's start building the circuit. For this, we'll first take the breadboard, and onto the breadboard I'll be connecting LM35. Now see the polarity, or see how I connect it. Now this is to be connected at the second or third part of the breadboard, so that we get the horizontal connections. Okay, so you might have require some time in putting it into proper slots. Okay, I have placed it properly. Now this thing, the first thing is our ground pin. Now I'll place a ground pin onto it. Yes, this is a ground pin. Then this second pin will be 5 volts, that is the VCC pin, and then this pin will be the output pin. Okay, so center one is the output, first one is our ground, and this is 5 volts. Now we have to connect it to the Arduino. Now this ground pin is connected to the ground that is available on the Arduino board, and 5 volts is connected above it, because 5 volts we have onto the Arduino board and the same slot. Then this is our output that is connected onto the A0 pin. That's it. So the connections are quite simple. 3 pins that are connected on the breadboard are going at the appropriate place. VCC going on to VCC, ground going on to ground, and the output pin is going on to the A0 pin. So the connections are quite simple. Now just one more thing that we have to do is we have to connect the Arduino with PC with the help of this USB cable. So we'll be connecting it in here, and we can connect it to the PC. Okay, so this completes with the circuit, quite simple circuit I feel. And now what we can do is, okay, so this completes our circuit. Now we can see the programming part, and we can see how the output is and how we can measure the temperature. Let's see the programming part. Let's see how to program it to get the desired results. As always, we have got two functions, void setup, void loop, and all the code goes inside it. Now setup part has initializations. As we have discussed earlier, we'll be requiring serial communication because the temperature is measured by Arduino board, and that is displayed onto the PC. So we require serial communication, and here we are connecting to A0 pin, therefore that is also required. So in void setup, we have got two functions or two instructions. One is pin mode A0 input, that means we are using A0 port or pin as an input, and then we have got serial.begin for serial communication at 9600 bit rate or baud rate. So the setup is quite simple. Now we have to talk about void loop function. Now before talking about void loop function, let us think what will be the output. Now suppose the output temperature is uh, 30 degrees, so we'll be having 0.3 volts as an output that will be coming out, and that will be going into A0 pin. Now A0 pin is what it is, analog pin, and it measures analog voltage, but it converts it into digital and it gives to Arduino pin, because we have an ADC in between pin and the Arduino board. So the ADC is converting these range of voltages into digital, and it is a 10-bit ADC. So it is from 0 to 1023. So 0 volts to 5 volts is converted into steps of 0 to 1023. So suppose if I am getting an output of 0.3 volts, so the output that I'll be getting at Arduino is approximately 60. Okay, because 5 volts is equals to 1023, so 2.5 volts will be something around 512. So 2.5 volts is 512. So if I get 0.3 volts, then the output will be approximately around 60. So we cannot take 60 because 60 is not the temperature around here. So the value that we receive from Arduino is to be multiplied by some factor which will scale it back to the temperature actually in degrees Celsius. So this is what we are going to implement. So now we can have, with this basics, we can have a look at our code. Void loop is the function where everything goes. In that, first we have float temp. That means we are declaring a variable whose name is temp, and the type is float. Float means what? It is not an integer, it is a decimal point, 3.33, 4.44, because temperature can be 31.33 and all the other things. Okay, so after that I have declared the variable called as temp. Then I am using an instruction analog read A0. So I am reading the value from A0 pin and I am storing that into temp. So suppose the temperature is 30 degrees, I am getting the value 0.3 volts, and that is being obtained from A0 pin, and that is stored into Arduino. After that, as discussed earlier, I have to multiply it by some scaling factor. So the scaling factor here is 0.488. So when you multiply the analog read value by 0.488, you will get the value directly into degree Celsius. So now my temp variable has the value in degree Celsius. Done. Then I have to print these things onto the output window, that is serial monitors. So for printing it, I am using 4 serial print instructions. First one is serial print temperature, that is in inverted quotes. So as it is, temperature will be printed. After that I am using serial.print and temp. Here I am not using inverted quotes because I want to print the value that is available in the variable called as temp. So first thing, temperature will be displayed. After that the value is displayed. Then I want to also display the Celsius thing. Therefore in next serial.print I am using star C. So this will be temperature 34 degrees and degree Celsius is printed here. And after that I am using serial print ln. That is done because I'll be continuously printing the temperature after 1 second. So I don't want everything to be coming one after another. So I'm using serial print ln so that it comes onto the next line. So here I have one output, then second, then third, then fourth, and gradually these all things will be there. So I hope the code is also quite simple because it is just 12 to 13 lines. Now what we can do is we can type this code onto this Arduino IDE, and we can upload this code and check whether it's working correctly. Okay, now let's see. We'll first upload the code onto Arduino board and let's see how the output is. Now this is the code that we have already seen in the presentation. The same thing is used. Now you can see that delay of 1 second is used because every 1 second the temperature will be calculated and that will be transmitted to the Arduino pin. Okay, now we'll first compile the code and check whether there are any errors. I don't think that we have got any errors here. Okay, now we'll do what is, we'll upload the code. So we are uploading the code onto the board. Okay, so it is being uploaded. Yes, now we have successfully uploaded the code. Now we can see the output. Here the output will not be there onto the board because we have not connected anything in here. The output will be displayed on the serial monitor. Now here, okay, so this is the output. The output is temperature. So the temperature of this place is 34 degrees. So 34.18 degrees is the temperature, and after every 1 second you are getting the value that is displayed. Now you don't get any variation over here because the temperature is fixed. So if you apply some water onto it, then the temperature will be decreasing. If you place it onto fridge or near the oven or something like that, you will get the variation of the temperatures. Okay. Now one more thing I would like to show here is that if you take a look at this, you will see there are two pins. One is transmitter and one is receiver. Now these two are having LEDs near them. Now this is used because this is to tell you that there is some data that is being transmitted or received by Arduino board. Now in this case, every second we are transmitting the data from Arduino board to the PC. Hence the LED near transmitter pin is glowing. So in the same way, you can see when we are uploading the code, at that time the receiver pin LED will be glowing. So these two things are indicating that there is some serial communication that is taking. With this, we conclude with this module. Initially we had seen passive infrared sensor, which is quite handy. You can use it in a lot of various application and various different ways. You can also use it in your room to detect that some person is coming or something like that. Then second part, we have seen temperature sensor LM35. That is also quite simple. But one thing that we didn't do is we didn't club it with some application. We didn't plan to work with an application here. In the next modules, we'll be using it for automation purposes. You can use LM35 for classroom automation, room automation, home automation, etc. In which, whether if the temperature goes beyond 27 degrees, 28 degrees, you can automatically switch on the fan, and something like this can be done. So in automation purposes and for monitoring whether the temperature is increasing, and for data loggers and all that things, we can use temperature sensors. So temperature sensors, PIR sensors, quite simple, quite small, quite cheap, but have got lot of applications. So you can use them in various other ways. Hope you like the module. If you have any queries or questions, you can find us on Facebook by the name Millionlights, or even you can find us on Twitter. For more such interesting courses, you can visit our website www.millionlights.org. Thank you.